Okay, so when we ended last time, like I said, we were looking at how to write equations of lines of all types. We looked at how to write y equals mx plus b equations. We looked at how to write equations of vertical and horizontal lines. And so the only thing that we really didn't get to is how to graph lines. And I'm going to show you kind of two brief ways that you can use to graph equations of lines. Because I am going to want you to be able to sketch a graph on your paper, okay, not just rely on the $100 calculator to graph it. I know the $100 calculator can graph it, okay? I want to know that you can as well, and that you can pull the details you need to. So here is the first version of graphing a line, okay? The first version is you get the equation in y equals mx plus b form. Can't spell equation apparently. There we go. Okay. Then you graph the y-intercept, because remember b is the y-intercept. And number 3 is from that y-intercept you're going to count your slope. And then the last step is you're going to connect the points to form a line. Okay. So just know we're also going to look at an alternative way. So if you didn't leave enough room to horizontally list another method, then you just need to maybe leave some space under it. Okay. Yes?
I can't see.
There's a seat right there. I mean, there's nothing I can do to make it much bigger than it already is. So, but yeah, I think maybe right there might be better. And then I'm not really sure why there's 3 seats that close, but there's also one over there. So maybe this row is just not so good. I think maybe even if you move that back seat back a little, I don't know. So try it out. Try some different locations. So. Okay, so we're going to graph, first let's graph this equation. 3y plus x minus 6 equals 0. Okay, so notice this is not in y equals mx plus b format. Okay, so we want to get it to look like y equals mx plus b. Okay, even if you're going to use your calculator, you need it to look like y equals mx plus b. So the first thing I'm going to do is move these terms over. So we get 3y equals negative x plus 6. Okay, you want to get y by itself, so what number needs to get out of there now? Divide by 3, right? When you divide by 3, you have to divide everything by 3, so sometimes we can forget that, but every term would have to divide by 3 when you're adding. So we end up getting y equals negative 1/3 x plus 2. Okay, notice, why did I change that to a negative 1/3? Like, what's the understood number in front of x since I didn't write one? The number 1, right? So negative 1/3 is really what you have, okay? So in other words, this is my y-intercept. We learned that last week, right? And this is my slope. So over off to the side, let's see if we can figure out what this would be. So let's go out 4 in every direction, and then if we need to go out more, we can. Okay, so the first step is get it to look like y equals mx plus b, because that's the information that we want. We want the slope, we want the y-intercept. Okay, so what do we graph first? The slope or the y-intercept? Always the y-intercept first. So we know it crosses the y-intercept at 2. Okay, and then let's talk about what the slope means. So let's kind of write these out. So I know we know this already. Y-intercept is 2, and the slope is, you can write the slope in some different ways, and I want to talk about that. So we could either write the slope as negative 1/3. Okay, if we write it as negative 1/3, what is this telling us? Remember, it's change in y over change in x, right? So what's the negative 1 on top telling us? Yeah, it's telling us to go down 1, okay, and then the 3 on the bottom is telling us to go right 3. So directionally, let's do that. From the y-intercept, we're going to go down 1 and right 3 and put a point there. Okay, but let's say we would have written the negative slope like this instead, because by the way, the negative sign can go either place. It doesn't matter. It's a negative 1/3 no matter what, no matter whether the negative one's on top or it's on the bottom. But if it's on bottom, what am I asking you to do? Go up 1, right, because the 1 is positive this time, and go left 3. Okay, so notice if you did that instead, you would go up 1 and left 3, and you would be here. Well, what do you notice about these 3 points? Yeah, still the same line, right? So it wouldn't have mattered which way you went, okay? Why would it have been wrong, though, to go both down and left? A negative over a negative is actually a what when you reduce it? A positive, right? So we want to make sure one direction goes negative and one direction goes positive. But honestly, it doesn't matter how you do that, okay? Whether you go down and right or whether you go up and left, you'll end up on the same line. Okay, so that is honestly my preferred way of graphing lines because it more mirrors what I feel like most of you already have some experience with. I feel like most of your high school teachers threw you a calculator and was like, here, graph it on the calculator, okay? And so you have to make it look like y equals to be able to graph it on the calculator. But there is a second method, okay? And so let's look at the alternate way. You also can find the x-intercept and y-intercept. Okay, and then you can graph both points and connect the dots. And sometimes this way, honestly, is easier. Okay, sometimes it's actually a really big pain in the butt to try to get y by itself. Sometimes y equals is maybe not your go-to method. And notice even in number of steps, this one's quicker. Okay. The thing is, though, that you have to remember how to find x and y intercepts, okay? But that shouldn't be too bad. So let's look at one, and by the way, this is actually more like what you will see on the comp test. There is one graphing line equation on your comp test. So let's say that I ask you to graph the following. 3x plus 4y equals 24. Let's make it a negative 3x. So negative 3x plus 4y equals 24. So instead of making it look like y equals mx plus b, this time I'm going to find the x and the y intercepts. Okay? So it's pretty simple to remember how to do these, right? You find either intercept by setting the other thing equal to 0. So if I want the x-intercept, then I need to set what equal to 0? Y equal to 0? Okay? So let's take my equation and do just that. So I've got negative 3x plus 4 times 0 equals 24. But what's anything times 0? Just 0, right? So that goes away, and I just end up with negative 3x equals 24. And then what would I do? If I want to know what x is, I need to divide by what? Negative 3. So I end up getting x equals negative 3 here, okay? Or the point negative 3 comma 0. Okay, so let's do the same thing for the y. So how do I find the y-intercept? Instead of setting y equal to 0, what would I set equal to 0? X, right? Whatever intercept you want, you set the other thing equal to 0. Okay, so if I set x equal to 0, let's see what that looks like. Negative 3 times 0 plus 4y equals 24. So notice with intercepts, one of them's going away every time, and you're just left with one of the variables left. So notice this goes away, right? And we just get 4y equals 24. So we'll divide by 4. So we end up getting y equals 6, or what? How would you write that as a point? 0, 6. So I'm going to make this pretty small, okay? Because we really don't need a lot of detail for this graph. We just need to make sure we go negative 3 in the horizontal direction, right? And then up 6 in the vertical direction. So I'm putting even less detail than I normally would. And then after you have 2 points, you can just do what with them? Just connect them, right? Okay. So either way, notice how many points do we need before we can draw a line through them? Just 2, okay? We could do 3 if we really, really want to. Like up here we had 3 only because we went a different way with the slope, right? We went 2 different directions. Okay, so it doesn't really matter to me kind of which of these 2 methods you kind of hold on to. Just know that on the comp exam, it's like the second one, like example 9, okay? Okay, so let's look at the next section, which is actually just a continuation of this one anyway. It's actually the same topic. So they weren't even that creative with their title. So I think like section 2.3 was called like slope and lines or something, and 2.4 is more on slope. In other words, we're still talking about slope just in some different ways. Okay, so hold on to all the things we still know about slope, right? We have a formula for slope. We know that slope is always represented by the letter M, but let's talk a little more about it, okay? So parallel lines are lines that never intersect each other. So let's draw a couple parallel lines. I think all of us kind of know what parallel lines look like in general. Okay, we could probably draw a quick picture of them. But what I want to talk about with parallel lines is in reference to slope. Okay, so what did we say slope was? It's a measure of how what a line is? Steep, right? So what would you say about the steepness of both of these lines compared to each other? It looks exactly the same, right? Like if you were to try to drive your car up a ramp that steep, they both look about the same steepness, right? So in fact, the slopes of parallel lines are the same always. So notice I'm putting a star by this because of the details about parallel lines. This is the main one I want you to know, okay, that slopes of parallel lines are the same. Okay, so we almost always talk about perpendicular lines when we talk about parallel lines, okay? So perpendicular lines cross each other, but they cross each other in a certain way, okay? So do y'all remember how they cross each other from another class maybe? Yeah, at a right angle or a 90-degree angle, however you want to say that. So they're lines that intersect at a perfect right angle. In other words, 90 degrees. Okay, so let's draw perpendicular lines. Okay, often you'll either see like a 90-degree mark or you'll see this right here. When you see the little box, that's trying to tell you that, hey, that's a perfect square there. It's a perfect 90-degree angle. So we know some things about the slopes of these lines also. They're definitely not the same. How can you tell they're definitely not the same? Yeah, they're going opposite directions, right? One is positive and one is negative for sure, okay? So here is what we know about the slopes of perpendicular lines. They are what we call negative reciprocals of each other. So that's a really long way to say you flip the fraction and you change the sign. So if one is negative, the other one has to be positive. And also, they're not necessarily going to have the same number slope either, unless the number is 1, because when you flip 1, it still stays 1. So let's say that I just told you that this slope was 3/2. Okay. Then what does that mean the slope of this one would be? Yeah, it would have to be negative 2/3. We'd flip the fraction, change the sign. So what we're going to do in this section is just kind of a revamping of a lot of the things that we did last week. So it's really not learning that much new stuff other than what I just went over. So you're still going to be asked to use those different equations of lines given different information. It's just that you're going to have to work a little bit harder for the information this time. Okay, you're going to have to remember maybe a little bit more facts. So remember, equations of lines always look like y equals to the first power, or y to the first power rather, and then x to the first power. Okay, so let's underline the information I was given. I was given a point, and I was given the fact that it's parallel to something. Okay, so which of the equations that we talked about last week, okay, by the way, what were they? I'll start you off. Slope-intercept was one of them. Do you remember what the second one was? Point slope. And then there was the general form, which we didn't learn all that much of, right? We didn't really do all that much of that. So which one uses a point? The point slope, right? So I want to use y minus y1 equals m times x minus x1. And remember, I need to know what goes in each spot, right? So I don't want to write this again because I wrote it last week in our notes, right? But what goes in for m in general? Slope, right? What goes in for x1? The x part of the point, right? What goes in for y1? The y part of the point, right? I'd say we have the point covered, right? What do we not really quite have right now? We don't really have the slope, right? So what we're going to need to do is we're going to need to find the slope. Okay, but we do have some information that could get us the slope, right? So we do have the line that's parallel to it, right? So what do we know about parallel slopes again? Still on the screen, it's on top. They have the same slope, right? So what do we really want to do? If we could find the slope of this guy, wouldn't that also be the slope of what we want? Okay? The problem is, does that quite look like it needs to for me to be able to pull the slope out of it? Not quite yet, right? In other words, how do I really want this equation to look so that I can tell the slope right away? Yeah, it needs to look like y equals, right? And that's not too hard to get on this one, right? We don't even have to divide by anything. So we could just add 2x to both sides and subtract 3 from both sides. Okay, so notice we'll get y equals 2x minus 3. So that's not my answer. That's just what this other line equation is, okay? So what do I want to pull from this? Yeah, so notice the slope here is 2, okay? And since I have parallel lines, what does that mean? It's got to be the same, right? So parallel line, the parallel line to this one also has a slope of 2. Okay, so notice now we have what we need, right? We know the slope is 2, we know the point is 2, 4, and now we just need to plug it in. Okay, so it's going to be y minus the y value equals the slope times x minus the x value. Okay, and then we talked about it last week. MyMathLab is going to tell you what form it wants. If it's asking for point slope form, you're there. Like that is point slope form. Point slope form looks like that. Okay, it looks like y minus a number equals m times parentheses x minus a number. Okay, but what if it, so we'll circle that. Like if MyMathLab says that's what it wants, then you got it. Okay, but what if it wants it to look like y equals? Yeah, then we just got a little bit of rearranging to do, right? We need to do distributive property, and then we need to move the 4 over, okay? So this is going to be y minus 4 equals 2x minus 4. And then last but not least, we'll add 4 to both sides. So it's okay that that minus 4 plus 4 goes away. What does it mean about our y-intercept then? What's our y-intercept since there's no number there? It's just 0. Yeah, it is the origin. That's correct. So 0, 0 is the origin. Okay, so notice these are both equations for this line. It's just one looks like point slope and one looks like slope intercept. Okay, so if you were going to graph this, and I'm not saying we are, but if you were going to graph it, what would you do? The y-intercept, where would you put your first point? At 0. And then what would the 2 tell you to do? First of all, remember that's the same as 2 over 1, right? So that would tell you to go up, what? 2, and to the right, 1, right? So I won't make you graph it, but that's how we would do it. Okay, so let's do a similar example where I give you the perpendicular slope rather than the parallel slope. So again, I want you to write an equation of a line. through 5, negative 9, and perpendicular to the following. So perpendicular to x plus 7y minus 12 equals 0. So you're always going to have some way to get the information that you need to be able to use either point slope or slope intercept form. Okay? So if we want to go through and talk about what information we know a point and we know something about the slope, right? So which equation do we want to use? Again, point slope, right? So I want to use y minus y1 equals m times x minus x1. Okay, and just like the last one, I need to find the slope. I just need to remember that perpendicular lines are different from parallel lines, right? So when we get there, we need to think about how that's going to be different. All right, so now what? Just like the last one, how do I want this equation to look so that I can pull the slope easily from it? Y equals. So I'm going to take this equation. This one is not going to be quite as easy to make look like y equals, but we can do it, okay? So first, let's get the y term by itself. So subtract x from both sides, add 12 to both sides. Notice that's going to give us 7y equals negative x plus 12. But I don't want 7y, right? I just want y. So how could I get rid of that 7? Divide. Just make sure that you divide everything by 7, even the 12, even though that's going to give us maybe something a little unpleasant. So I get negative 1/7 x, right? Because the understood number in front of x is just 1. And then plus 12/7. Okay, so the slope here, the slope of this line is negative 1/7. Okay, but I don't really want that slope. What do I want? I want the perpendicular line's slope, right? So what would the perpendicular line slope be?
Negative 7/1.
Yeah, well, not negative though, right? Yeah, so notice it already has a negative, so we're going to flip the fraction and change the sign, right? So the perpendicular line slope is m equals 7/1, okay, or 7. So we have to pay attention to the fact that we knew it was perpendicular, not parallel. When it's parallel, you just use the same slope. When it's perpendicular, you flip the fraction and you change the sign. But at any rate, notice now we're ready because we have a slope and we have a point. Okay, so now we're good to go. So we've got y minus negative 9. Notice we end up with a double negative there. We'll talk about that in a minute. But it's y minus whatever the y value is equals what? Y'all tell me. 7 times parentheses x minus the x value, which is what in the point? 5. Okay. So if you were asked to do point slope, the only thing that you'll need to clean up is this minus a negative changes to a positive. Okay, so if you're asked for point slope, this is it. And kind of like I told you last week, but maybe you've forgotten, a lot of times my math lab's going to ask for this form first. You put it in, press enter, it'll tell you yes or no, you did it right, and then it'll later then ask you to change it to y equals. Okay, so that's kind of why we're doing that for every problem. So distribute the 7. So we get y plus 9 equals 7x minus 35. And then what's the last final step? I want y equals, so what needs to go? The 9, right? So I'll subtract the 9. So I end up getting y equals 7x minus 44. So same equation, okay, well, same line equation, just different formats. So this would be the slope-intercept form of the same exact line. Okay, so if I asked you to graph this, I probably wouldn't because of the high slope or the high y-intercept, right? What would you graph first if I asked you to graph it? You would plot the y-intercept at what? Negative 44, and then from there you would count the slope as what? 7 over what automatically, if it's a whole number, over 1, right? So you would go up 7 and over 1, right? So probably wouldn't ask you to graph something like that just because the y-intercept's kind of big and ugly. Okay, So let's do one more where we write an equation of a line, and then we're going to look at something just a little different. So I want you to write an equation perpendicular to x equals 4, and then through the point -2, -3. So this question is different. I'm giving you different information. But if you know what you're looking at, it's actually a little easier than the ones that we did. It's definitely less work. But you do have to kind of think about what we're looking at. Okay? So some things that we want to pay attention to. We know that it's perpendicular to this, but let's talk about what this is. This is one of our special cases, if you vaguely remember from last week. I know it's been a minute. Okay? But what kind of line has an equation of x equals a number without anything else there? Do you remember? Try the other one. Vertical. You knew it was one or the other, right? So this is going to be a vertical line. X equals 4 is a vertical line. I want the perpendicular line to a vertical line. Okay? What is perpendicular to a vertical line? A horizontal line. So what I want, right? I want a horizontal line, since it's going to be perpendicular to what I started with. I want a horizontal line through the point -2, -3. Okay? So let's not overthink that. If vertical lines look like x equals, what do horizontal lines look like? Y equals, right? And we have a y value. We just need to pull it out, right? What's the y value in that point? -3. So like that's it. There's not really any work to show. So like once you figure out what it's asking for, it's really not so bad. Okay? What if it would have said parallel to the vertical line? Then it would have been x equals, since they're similar, right? Since they're parallel, and it would have been x equals -2. But since I said perpendicular, we wanted the horizontal version of that line. Okay, so let's keep talking about slope, but we can do a version of slope. Remember, slope is just a rate of change. And so a lot of times we want to look at what's called the average rate of change rather than just straight up rate of change. So think of like rate of change as the speed of your car, but average rate of change would be like your average speed on a big trip or something, or maybe your average speed on your commute to school today. Okay? So average rate of change is a rate of change over a period of time. So think of regular rate of change as just a specific slope, whereas average is a slope over a period of time. All right, so let's go ahead and write that down. So let's say that I take a car trip and my average speed for 3 hours was 65 miles per hour. Okay, then that means that that's my speed on average. Okay, it's not necessarily constant. I guess it could be constant if I set the cruise and I never, ever, ever changed my speed in that 3 hours of time, but that's not very likely, right? You'd have to be like driving through Montana or something where you have no stoplights, no nothing. Okay. So what's more likely if my average speed was 65? It's more likely that sometimes I was going faster than 65, right? And then sometimes I was what? Going slower, but overall in the 3 hours I averaged out to 65. That's much more likely. So we do have an average rate of change formula, but I want you to notice that it's actually not much different than another formula we've already been looking at. Okay? So here's the formula, and maybe you can eyeball it and tell me what you think it looks awfully similar to. So it's f of x2 minus f of x1 on top, and then over x2 minus x1. Okay, so what is that super similar to? Yeah, this is just another version of the slope formula. Okay? I consider it a little fancier version of the slope formula. Okay, because remember, f of x is really just what? What can we replace f of x with most of the time? y, right? So it really is change in y over change in x, okay? It's just written in a different way. So let's look at a couple of problems where I ask you to find rate of change or average rate of change, but I want you to notice that really what I'm doing is just asking you for essentially a slope. It's just a slope over a period of time. So let's say this is my function, and we're going to do two parts to this. I want you to find the rate of change if your two x values are 5 and 3, and then skip over a little space, and I want you to find the rate of change if your x values are instead 8 and 10. Bless you. Okay, so I'm going to abbreviate rate of change, ROC, rate of change. Okay, so my rate of change formula looks like this. I know that I'm going to have some f of x values on top, and then I'm going to have my x values on bottom. So I'm going to start with what I already know. I already know my x values. What are they for part A? 5 and 3, right? So specifically, we're going to do x2 minus x1, so we're going to do 3 minus 5. Okay, so what needs to go on top then? The f of x2 and the f of x1, right? So we really just need to kind of figure those off to the side. So we need to figure out what is f of x2 and what is f of x1, okay? But we already know that x2 is 3, right? So really what I'm asking is just find f of 3, and we know how to do f of a number, right? What does f of a number mean? Whatever that number is, what do you do with it? You plug it in for x, right? So instead of x squared plus 2x, we're going to have 3 squared plus 2 times 3. Okay, do exponents first. Sorry about that, let me move that up. Exponents first, so we'd get 9 plus 6, so what do I get? 9 plus 6 is 15. Okay, so I'm going to circle that. I'm going to use that in my fraction above. So for f of x1, I'm being asked to find f of 5. Okay, so let's plug that in, right? So that's going to look like, plug it into this equation that I'm pointing out right here. So it's going to be 5 squared plus 2 times 5. So 5 squared is 25, right? 2 times 5 is 10. So what do I get for the final answer here? 25 and 10 is 35. So notice, make sure you list the x2 one first. So what's going to go here are these values. And then we just figure out what this simplifies into. So 15 take away 35 is negative 20. And 3 minus 5 is negative 2. Okay, so what does that reduce to? What is negative 20 over negative 2? 10. Okay, so we're going to come back and explain that answer here in a minute, but let's compare it to the one that we get for part B. Okay, so our average rate of change for those x values is 10. Okay, so let's do the same thing over here. So I know I have a fraction, right? And I know I've got 10 minus 8, x2 minus x1. So just like the previous one, what do I need to know? I already know the x's. I just need to know the y's, right? The f of x type stuff, okay? So what is my f of x2 versus what is my f of x1? So f of x2 just means f of 10, right? Because x2 is 10 for this part, for part B. Okay, so what does anything that looks like this mean? It means go plug in what? Go plug in 10, right? So we're going to have 10 squared plus 2 times 10. So we get 100 plus 20, which gives us 120. So I'm going to circle that. That's going to go in my fraction. F of 8, right, because that's what x1 is. x1 is 8. We're going to do 8 squared plus 2 times 8. So that's going to be 64 plus 16, which is 80. Okay, you don't have to do these bigger number additions and subtractions in your head, you can use a calculator. But notice this is going to be 120 minus 80. Make sure that you're consistent. Okay, so you started listing x2 first on the bottom, so you need to do the same thing on top. So notice what we get here. We get 40 over 2, which just reduces to what? 20? Okay, so which one is a higher rate of change? Part A or Part B? Part B is a higher rate of change, right? So let's kind of describe what's going on here. So we're going to describe just briefly what it means. What it means here is, on average, y changes by 10 each time x changes by 1. That's what a slope or a rate of change of 10 means, right? Think of it like 10 over 1, okay? So what's happening here instead? What's happening on average to y? Yeah, y changes by 20 every time x changes by 1. So of course the rate of change here is bigger, right? It represents a more rapid increase in values. And it's important to say average simply because it's average rate of change, that's it. Okay, so I don't want you to think of average rate of change as its own thing. It's really just a glorified what formula? Slope formula, that's all it is, okay? It's just a little bit different version of slope, okay? Okay, so last problem on this topic, and then again we're going to look at something else. All right, so unfortunately this is a word problem, so we're going to have a little bit of writing here. I'm going to keep it as brief as possible. So in the year 2000, 47% of Americans read the newspaper. I think we know just with common sense that amount's going down, right? So let's say that the rate that it decreases by is on average 1.2% per year. Because where do people look for their news most of the time now? Online usually, right? Maybe television, but honestly probably online is probably the biggest source of news now. As scary as that is, because you can't really believe much that you see online. All right, so part A is I want you to write a linear equation representing who still reads the newspaper. Part B is I want you to predict the percentage of newspaper readers in 2021. And then lastly, I want you to tell me, when do you think, based on this pattern, when will the percentage of readers be 20%? So we know it's going down every year. The question is, how long is it going to take to go down to 20%? So word problems aren't something to be scared of. We can do word problems. We just have to sometimes think about them a little bit harder than we do regular questions. Okay. So just like we normally do, let's go in and underline the information that we think is significant, okay? 47% is probably significant. The fact that we're decreasing is probably important. And the 1.2% is probably important. Okay, notice those are all the numbers, and then the word decrease just lets me know that it's probably going to be a negative number, okay? So let's look at part A. Okay, I want to write a linear equation. Remember, I've been using a lot of point slope form, but what's actually the easiest form of an equation of a line? Yeah, the easiest version is the y equals mx plus b thing, right? The slope intercept. Okay, and I think I actually have the correct number, or the correct information rather, to be able to use this. Okay, so first, let's just kind of make a definition here. We're going to let x equal the number of years after 2000. Because notice the problem tells us that it starts in what? When are they starting to kind of keep track of this? In 2000. Okay. So let's talk about what that would be. Okay, so it's going to look like y equals. So which number is talking about a slope? In other words, which number is discussing a rate of change? The 1.2%, right? But instead of saying positive 1.2, I'm going to need to use negative 1.2. How come? Because it's negative, right? It's going down. Okay, so I'm going to say negative 1.2%. Notice I don't even have to change like the percent to a decimal or anything goofy like that. Okay, I can just keep it as a percent if I want. And then where do you think the 47 is going to go then? In other words, what would be the y-intercept for this problem? 47, right? Think of it like this. When we graph a line, where do we start? We start at the what? At the y-intercept, right? So in this problem, our percentage that started reading the newspaper or that was reading the newspaper at the starting date of 2000, that's going to be our y-intercept. Okay? So notice now we have an equation where we can use that equation to do parts B and C. Okay, so let's talk about 2021. Okay, what does 2021 mean if I'm using X to represent the years after 2000? So what do I need to use for, so basically, think of it this way. It's 21 years after 2000. Okay, so what do I need to use for X then? Yeah, just use X equals 21. Okay, I don't need to use 2021 for X because I'm talking about only the years after 2000. Okay, so that's going to be not so bad, right? We're just going to plug it in and we're going to use a calculator to tell us what we get. So we're going to use the equation and we're going to plug in our X value of 21. So let's see what we get. I'm going to try to not have a mess here. All right, so negative 1.2 times 21 plus 47. So we end up getting 21.8. Okay, 21.8 what? Think about what part B is asking. 21.8 what? Percent. Okay, so if you wanted to give like a short sentence, what would you say? In 2021, we expect how many people to be reading the newspaper? 21.8% of people are going to be reading the newspaper for their source of news. Okay, so last but not least, okay, notice that I asked when, right? Okay, if I asked you when, what does that mean? What do I not know if I'm asking you when? I don't know what year, right? In other words, I don't know what X is, okay? So I don't need to plug in 20% for X, because remember, X is the number of years after 2000. Where would I actually need to plug the 20 in for? Yeah, 20, the Y is the percentage, right? So I actually need to do this right here. So I use the same equation, but this time I know the percent, I don't know the year. Okay, so now let's see if we can solve this, and we have a calculator to help us, right? So subtract 47 from both sides. So we get negative 27 equals negative 1.2 X. Now what? If we want to know what X is, what would we do? Divide by negative 1.2. So let's see what we get. Negative 27. Not 0.27, but negative 27, divided by negative 1.2. So we end up getting X equals 22.5. Okay, but that's not a year, right? So like, what does X represent again? Years. This is years after what? After 2000. Okay, so then how would I write the year then? It's going to be about halfway, right? Halfway through what year? Yeah, so halfway through 2022, right? We wouldn't ever write the year as 22.5. Okay, but we can talk about that as halfway. Okay, so it's kind of like a lot of different ways to write equations of lines. So it really doesn't matter what kind of problem you have. What are the two main forms of equations of lines that we've talked about last week and then also today? What are the two main forms that we use? Y equals mx plus b, what's that called again? That's not that one. Slope-intercept is y equals mx plus b, right? And then what's the other one? Point slope, which is the y minus y1 longer one, right? So you need to really be good at using both of those formats. Okay, so we're going to basically just go as far as we can in the next section. I don't expect that we'll finish it. So I want to give you a handout because I don't want you to have to sketch a bunch of really detailed graphs. But if you like to take notes in one part of your notes, then you could like skip a page and paste this in later if you want. You can find this in your ebook too, but just to be real honest, I don't know how many of us are looking at the ebook, so I think it might be a fair assumption that not much. We're not looking at the ebook all that much. Oh, I don't think you need to. You can have to, but I don't think you want to. Okay, so I want us to look at this handout together. We are going to take some notes on this. Like I said, we're going to get as far as we can. But just for right now, I want us to look at it together. Okay, so if you want kind of a title, this is going to be section 2.5, which is titled Transformations. Okay, when you transform something, what do you do with it? You change it, right? That's why transformers are called that, right? They change from cars to whatever they change to, robots. Okay, so the first thing is I want you to make sure that you know these basic graphs, and we're even going to add one to it. It's just that this particular chart didn't show them all. Okay, so I want to kind of go just kind of slowly in order, and I want to talk about what we know about these graphs. Okay, so I didn't give you this handout for nothing. I didn't give you this handout so you never referred to it again. So this is information that I kind of want you to know. So let's look at the first two graphs. So what do we notice about both of these? This one and this one. They're both what kind of shape? They're both linear, right? They're both lines. Okay, so this is a specific type of graph, right? This is a specific type of line, rather. What kind of line is this? Horizontal, and this is like a diagonal line, right? So basically all linear functions look like this. They just might change the slope or shift over or something like that, okay? So notice down here it shows you the domain and the range, okay, and all that kind of good stuff. It also shows you what the equation looks like. So anything that looks like x to the first power is going to be a what shape when you graph it? Well,
Or a diagonal line.
yeah, a diagonal line of some sort, okay? So let's look at the next graph. Okay, so look at what I say this equation looks like, right? What's those bars mean? It might have been a little bit. I know you can't see up here. I want you to look at your own. Yeah, absolute value is what the bars mean, right? So in other words, all absolute value graphs are going to look like this. Again, just maybe shifted over, maybe turned upside down, maybe made skinnier or fatter or something like that. But anytime you see absolute value of x, what do you kind of need to think about the graph? It's going to look like a what? Like a V shape. Okay, let's move on to this one. Okay, what kind of shapes give us parabolas? That's one maybe you should already know from another class. X squared equations give us parabolas, right? So this is the simplest parabola we can have, right? It's literally x squared, okay? But if you have other numbers thrown in there and it's just something x squared, then again, the shape's not going to change. What is any x squared equation still going to be shape-wise? It's going to be a U/parabola looking shape, right? But again, we might be transforming or changing it in some way, okay? Next one, square root function, okay? These two are kind of buddies, okay, the two that I'm pointing at right now. Square or quadratics and square roots are kind of buddies. So how do you think this one relates to this one? What does it look like happened to it? Not really, I know what you're thinking. Not reciprocal, because that would mean flip a fraction. But it is like the inverse, which is what I think you're thinking, okay? But notice, like picture-wise, what does it look like we did? We cut it how? Cut it in half, but then we also did what to it? Turned it to its side, right? And notice that's actually exactly what we did. Can anybody think about why you think this side's missing? What kind of numbers are we not really allowed to take the square roots of? Negative numbers, so that's why this side is missing, okay? We can't easily take the square root of negative numbers. Remember, we get imaginary results. So that's why it literally is a sideways half parabola. It's missing that negative half because it can't be negative, okay? Lastly, and then we're going to sketch one that's kind of a buddy to this one, okay? So what is this graph called? Cubic functions. So anything with a third power is going to look like this curve. Notice how it goes up one way, goes down another way, okay? So we're going to talk about how we can change this graph in some way, okay? And so the one that I want you to add, we're actually going to add it right under this one, is called the cube root function. Okay, the simplest cube root function that you can have is literally just the cube root of x. Okay, now if you look back at the buddies, the quadratic and the square root, what did we say this was again? We did what to the square function? We turned it sideways, right? And we took half of it, okay? Well, it turns out the cube root function is also turned on its side. So this is what a cube root function looks like. It curves up this way and then down and back that way, okay? So we turned it on its side, but what do you notice that it's different than these two buddies? There is a negative here, right? Can you think of a reason similar to what I just said before about square root? You can't take square roots of negative numbers, but can't you take cube roots of negative numbers, okay? In other words, the cube root of a negative number is fine, right? We don't have any problem taking the cube root of a negative number. You don't have to write it down, right? But the cube root of -8, for instance, is what? We'd be looking for the number times itself 3 times that gave us -8, right? Which would be what? -2, okay? So this is A-okay, whereas the square root of -4, not so okay, right? So that's the difference between cube and square root. We can take cube roots of negative numbers much more easily than we can square roots of negative numbers, okay? So the point is, I don't expect you to know it right now, but sometime before next week, I want you to commit these 7, really just 6 graph types to memory. The reason I say it's just 6 is even though we added this one, I kind of consider this one to be combined with this one, right? So how do you know that, for instance, how do you know that something's linear from just looking at the equation? So I want to make sure we do this before we move on. How do you know something's linear just from the equation? X will be raised to what power? 1, okay? So it's plain old x to the first power are linear, okay? Let's come down here. X squareds are what shapes? Parabolas, right? U shapes. Absolute value x graphs are V's. X cubed graphs look like this, right? And then we have kind of the root functions, right? Square root functions are like sideways half parabolas. Cube root functions are sideways cube functions, okay? So notice how like there are 6 to remember, but there are 2 that are paired up that I think if you remember one of them, you kind of can get the other one for free. Okay, so based on these transformations, let's talk about how we can change them. And again, we are not going to be able to finish this, and we're just going to pick back up with this next week like we always do. So I want you to keep this handout. That's why I put holes in it. So either you need to keep it in a notebook, a folder, tape it to your notes, I don't care what. Just make sure you have it. So we already mentioned this, but the word transform means to change. So we're going to talk about how we take these common graphs that we just mentioned and how can we make changes to them. Okay, and just so you know, there are 6 major types of changes that we're going to discuss. And again, your calculator, consider your calculator your backup tool. It is not supposed to be the end-all be-all and the only way you know how to do anything. Okay? You want it to kind of back you up and kind of confirm what hopefully you already know. Okay? So the first type of change that we can have is a vertical shift. MATLAB calls this a translation. So when you see the word translation, you need to just think that it's a shifting. Okay? So because it's a vertical shift or translation, it means that the graph is going to move up or down. Well, yeah, so either one of those. Okay, vertical would mean up or possibly down. Okay, so here's how you're going to know that a vertical shift needs to happen. Your function, whatever it looks like, is going to have a number added or subtracted to it. Okay, so I'm going to give you an example in a minute, but this is how you tell that there's a vertical shift that needs to happen. You will have a number added or subtracted at the end of the function. I just cannot write today. And a number added or subtracted at the end of a function shifts the graph up or down by C. So I want you to keep your hand out where you can get to it. So let's look at an example and we're going to sketch it. Okay? If I asked you to describe what absolute value of x minus 4 would look like, given the handout that I already gave you, okay? So first let's talk about it, right? What does the absolute value of x mean about the graph? Like what kind of shape did we say absolute value was going to be? It's going to be a V shape. Okay, so it's definitely going to be a V shape, but we do have something happening to it, right? What's the minus 4 going to do to our V shape? Yeah, so this is going to shift it down 4 units. Okay, so this is going to be a V shape, but you want to shift it down. So for most of these on MATLAB, it is literally just going to ask you like a drop-down menu, and you're going to have to pick whether it's up or down or left or right, and then tell it how many units. Okay, so notice, let's sketch a graph of this real quick. Okay, so notice, we actually need to know 2 things. We've got to know what the V shape looks like originally, and then we need to change it in some way, right? So I'm going to show the original with a dashed line, but it's good for us to practice these anyway. Okay, so this is the equation y equals absolute value of x. I made it dashed because it's not really my final answer, right? It's not really the graph that I'm looking for, right? The graph I'm looking for, right, is going to be the one that's shifted how? Down 4 units, right? But it doesn't change shape, right? It stays a what kind of shape? A V, right? So it's going to be a V. That marker is crappy. So it's going to be a V shape, but it's just going to be shifted down. So I don't want to do another one, but how would it have been different if it would have been a plus 4 at the end? It would have been same shape, right? Still a V shape as long as I didn't change the equation, but I would have shifted it up 4. Okay. How would it have been different? Again, I don't want you to write this down necessarily, okay? But how would it have been different if I would have changed it to x cubed minus 4? So we would have been making the same change, right? But what would have been different?
It wouldn't have been a V.
It wouldn't have been a V, it would have been a what kind of shape? I mean, there's no name for it, right? But it kind of curves up and then curves down, right? So you got to know 2 things. What does my original look like? And then what change am I making? Okay. Okay, so that's vertical shift or translation. So let's talk about horizontal shifts and translations. So translation just means, again, a shift. So don't be surprised when you see that word on MATLAB. Okay, so a horizontal shift is not going to move the graph up or down. How's it going to move the graph? Left or right. So side to side, right? So moves the graph left or right. So here's how you'll know that this needs to be something that happens. You're going to see a plus or minus some number that we call C, but notice instead